Okay, so this -1 here, I am not certain what that should be. Um, uh, what's the width? As it appears, and this is, how is this calculated? Um, or it might be number of tiles on the X. The max value. I almost just want to seal this value because I feel like that would be correct. If we had whole numbers, if we were working with whole numbers, I believe this would be the correct formula. But because we're not, I believe this needs to be sealed. And then, well, this doesn't. This kind of, I think this needs to be sealed, but then also I still think that, okay, well, if we look at the debugger, so let's say we sealed the upper bound here. Well, if we sealed that, that would be 4, and this would still be out of bounds. So I think that maybe we don't need to seal this because this is still basically correct. But it's this that's kind of out of bounds because we have a 4, and if we sealed this to 4, then this wouldn't be less than 4 because it's equal to, and that would be out of bounds, right? Because it's like having if it's a 0 to 63 tiles on a 64 by 64 tile, then you're out of bounds because this should not be equal to the width of the entire tile. Or sorry, this is height because this is y. So this value should not be equal to the height of the entire tile, which if we sealed that, that would be 4. 4 and 4, they shouldn't be equal. They definitely should not be equal. So even though I'm trying to figure out, oh, should I seal this or should I not? Well, let's not think about that anymore because we know this has to be wrong. This is off by 1. It's definitely off by 1 error. So let's look at where we are calculating that. Okay, so here we are. And so something about this is... Oh, God. Wrong one? Oh, something about this is off by 1. Oh, that's interesting. And... Oh, yeah. And I remember we were asking for trouble if we were modulating by, we were asking for trouble if we were modulating by a fractional value, right? So we need to somehow, make this into an equation that's not modulus, right? We need to like subtract something. Modulating using fractions is asking for trouble. And should we just write all elite like this, asking for trouble? Okay, yeah, sure, why not? Okay, so yeah, modulating by fractions, like having these be fractional values is yeah, that's asking for trouble. So we need to, rather than modulus, we just need to like subtract by a certain amount to like get this truncated. And so what would that be? So that'd be like LDX minus, and then it's going to be like the width, and it's times something, right? And then same thing with this. It's going to be LDY minus the width of a single tile, or the height of a single tile as it appears. And then also that's going to be multiplied by something. And I think that would be multiplied by... that would be multiplied by the local tile on the source. So we're going to look at the source, but we want the local tile value. So let's Control Shift F2, clear all our breakpoints, put 2 breakpoints here, and then we can we can obnoxiously color this here so that we can get back to it later. Or actually, Control 0 first so that all the other stuff isn't highlighted. I'll just color these 2 lines so we got something to remember to come back there. And I know we have the tile X, tile Y, or the source X, source Y, but we need to localize those values. So source X, source Y, and then we have some equation here. We got LDX, LDY. So I believe all we got to do to get, and this is the destination. Okay, so we need, okay, so that shouldn't be too bad. I mean, we should already have, okay. So, we got a lot of stuff going on here. What is the current tile value of the pixel being drawn in the destination viewport? Not sure if this makes sense. So I know I made this earlier, but does this code mean? I'm not even sure what this code means anymore, so we'll reevaluate that later. So really what I need is that LDX. So we need something like LDX, LDY, but it's going to be on the source. And we're not iterating through the source, so we have to derive those source coordinates. So SX, right? And here's where we're deriving SX and SY. So we just need like the, it's like the SX but local. And if we have SX local, yeah, so where are we asking for trouble again? We're asking for trouble over here. Another thing is, we might not... I'm not sure if we should floor this. Should we floor this? Okay, yeah, but the source axis always needs to be on a tile. There's no sub-pixel precision on the source coordinate. Okay, so I know the value we need. We need to get the we need like the source x coordinate, but we need it local. Yeah, the source coordinate, but it's local. So it's var, and I don't know. We could type it like that, but that's looks kind of confusing to me. Let's So it's I don't know. I'm gonna do this because so since I'm kind of like sick of this, I'm gonna go way up here, and I'm just gonna make something called var loc loc equals local coordinates values. So this is a container, so I'm just making a container for local values, and then we'll have like local.sx, and then we'll have local.sy. Does that make sense? Yeah, okay. And then we'll set that to 0, and then we'll do like an object.cls. And we'll seal this object. And we don't really want to construct this object in here every time they do mapping call. We want to put this object somewhere else because we're going to reuse it. I don't really want to create it and destroy it on the fly with garbage collection every iteration, but let's just keep it like that for now. And we have the sx and sy object.seal, and then now we have like a kind of a variable name that's pretty clear and not too ugly looking. And we can go find our sx and our sy calculations here, and we're just gonna say SL for source local. Just gonna add this in here like this. SL source local loc dot, and then we'll do like this loc.sx loc.sy like that. Okay, and then all we need is all that is it's the sx value, and then minus wherever the upper bounds is of the source viewport. So rec vp0 dot x1, and then loc.sy, so sy, but so the source tile coordinate as a local coordinate on the source would be something like this, right? Oh, oops, wrong one. Sorry. So this is VP0 is the destination, and we want this, right? So if we go, let's do we have these rectangles in here? Okay, so they're here, right, in the comments, but I'm using SRC here. So let's go back down to, so it's rec SRC. I'll make a note here that rec vp1 is equal to rec SRC, right? Just a little note there. And then bam, bam. So this is the upper bounds on the x and y, and these are inclusive. And so we're going to take... oh, wrong, and wrong. Lower bounds, right? We want the lower bounds. We want the origin, right? So if this, if the rectangle is at, if it's at 0, 0, right? We're going to subtract 0, and then the global and local coordinates are going to be the same, right? Because there's no translation. So sx, sy, x0, okay, and that's the source. Okay, so we got these local coordinates that we can do something with. I'm just gonna highlight these. And then I'm gonna go back down to the other highlighted area in our code. Right, and we had this, and it's like times something. And what is it times by? It is times by this, sx and sy. And we'll remove the coloring now. Okay, so the tile internal coordinate on the x and this is the this is on the actual well, this coordinate kind of doesn't matter if this is the source or the destination, this coordinate, right? Because it's inside the tile, right? But it's been normalized into a, but it's not been normalized, right? It's in a range from 0 to whatever the size of the tile is. So it's like a non-normalized value. So we could probably work on normalizing it later to give it like a value from 0 to 1, which might make sense. I really want to keep it as non-normalized coordinates because of how I want to map this later. So, you know, I'm going to keep non-normalized. So keep go non. So non-normalized. So I'm not going to put it. I'm not going to make these values between 0 and 1, right? It's going to be the value is going to be between 0 and however big the tile is minus 1. Okay, so the width of a tile as it should be seen on the destination viewport minus the local tile value, so we can figure out how much is used up. In this, so minusing this is should get like a similar effect to this modulation, but it's going to be more friendly for working with fractional values, because like modulating by a fractional value, that seems like trouble. So I think we're good. I think we're good to go. So another thought is, you know, what's the upper bound for this SX and XY? Like, what is the highest value it can have? I'm gonna go look at the local SX SY for a second. Make sure that it's that it starts at the correct value. So that's 0, then that would be correct. Okay, no, I think that's good. I think that's good. Okay, let's give it a run. And stop, refresh, and look at the console. What now? Oh, great. A NAN. That's yeah, that's what we need in our life. Okay, well, let's keep on looking. Let's see where that's calculated. Oh, interesting. NANs. NANs over here as well. What the fuck? So did we not calculate that? Because I swear to God we calculated that. Uh-huh. Yeah, JavaScript. Fucking JavaScript, man. So it's like, the annoying thing here is even if we use object.seal on object, that'll make sure that we can't add a property that doesn't exist. But even if you're using strict mode, it's still not going to complain if you try to access something that doesn't exist, which is exactly what we're doing here. That's why it's undefined, because I used x_0, not x0 like that. So this, so let me go over to the code, and just getting sick of this shit. So right here, that should be _0 like that. So let's go refresh and hope that things work, because I'm just getting so sick of this. And it's still not working. We're still getting an error. Let's look at the... Okay, I'm going to start another video.